Two. On this infinitely many, we've said up to this point there's infinitely many, and if you checked your work before, they said that it gave a expressions to find one of the variables, and we will do that.
I
So
can't draw them things.
you don't need to draw those things. Okay, so a matrix is an array of numbers. Let's see if this works now. Oh, it does work. Okay, a matrix, all it is an array of numbers. That's it. You've seen a matrix before. This is an infinite looking matrix. It's no big deal. All I want you to know is we name it by rows and columns. Okay? Rows go horizontal. Columns go up and down. Should make sense if you actually think about what a column is. If a column is laying down in a building, you got problems?
Yep.
Yeah. You're squished. And in order to have a column, don't you have to start with a row first? Start with the bottom and go up, right? So we name matrices rows by columns. If your rows and columns are equal, it's a square matrix. And then we have main diagonal. Main diagonal is these positions. This is A sub 1, 1 because it's in the first row, first column. A sub 2, 1 is what row, what column?
Second row, first column.
Second row, first column. Everything in a matrix is row, column. Everything when they talk about matrix is row, column, row, column, row, column. Okay? The biggest thing you need to know here is how my dimensions are. It's rows by columns. That's the biggest thing you need to know on that whole slide. We call those shape, order, or dimension, or size, not shape. Size, order, or dimension means the same thing. Good? Maddie, Tori, you guys good? You sure? Okay, so determine the order, the size, the dimension. Those are the things. Okay? So we have A. How many rows, how many columns? 1 and 1, right? So it'd be what? 1 by 1. Yes, and it is a square. Okay, B. 1 by 4. I got 1 row, 4 columns. C. 2 by 2. And D. 3 by 2.
That's what I said.
Okay? A row matrix is a matrix that has 1 row. How many row matrices do I have?
There's 2.
There's 2, A and B, right? Okay. A column matrix is a matrix with 1 column. How many do those do I got there? 1. A. A is a row and a column matrix, isn't it? Those are just some little things that come in handy when you're reading the book, but just some side notes. But if they ever ask for order, size, or dimension, they're all asking for the same thing. Am I good? Good now? Okay, so we have a system of equations right here. We are going to write that in a coefficient matrix and an augmented matrix. And after today, you're only going to do augmented matrices. So let's look at it. Okay, here's our system, yes? What's in a coefficient matrix? The coefficients. The coefficient is the number in front of the variable, correct?
Yeah.
Okay, so I have 1, negative 4, 3, negative 1, 3, negative 1, 2, then what? 0, negative 4. This is the x column, the y column, and the z column. So what's different with the augmented matrix? What did I do?
You added the answer.
I added the answer. So I have x, y, z, and then the answer. And these little dots are like what?
What do you think?
They're
Like equal signs. Okay, this is what it is. You have to put the dots. I always get people that draw a straight line. You shouldn't draw a straight line. But don't put one dot. Why not one dot?
That's times.
That's multiply, right? I just literally go like this every time. But some people want to make dots. So if you're making dots, do 2, I guess. But just, it's a dashed line. So people make that a bigger thing than it needs to be. So coefficient matrix just has what in it? Coefficients. Augmented matrix have a coefficient and a solution matrix together. It's augmented. It's what this line you actually say it's. So do you see in this system equation 1, 2, and 3? See that? So what we are going to do is take a system and clean it up. Won't it be easier to work with it like that? Yeah. So this will be row 1, row 2, and row 3. We will talk about them in rows. We won't say equation anymore. It's row 1, row 2, row 3. Good?
Yeah.
Okay, so write both the coefficient and augmented matrix for the following system. So matrices have brackets on both sides, yes? I like to go columns, but that's my choice. You can go rows, it doesn't matter. I will tell you that you need to make sure you are giving yourself plenty of room between your numbers. What matrix did I just write? The coefficient one. And then to augment it, I do exactly the same thing. And add my solutions. That looks like an S. This is not going to be an assignment you are going to save paper on. If you are trying to scrunch everything up, you're going to misplace where you're at. You need to find a way to follow what you're doing because we're going to have a matrix after a matrix after a matrix after a matrix. And we're going to be doing equivalent matrices where we talked about equivalent systems. Friday, it's not Friday, Tuesday. We're going to be doing equivalent matrices. So we're going to be multiplying by a non-zero or combining two rows, things like that. So if you're squishing things up, and the biggest mistake is when people go from here to here, they don't stop and make sure they've brought all their negatives with them. somehow a 2 turns into 5, that kind of thing. So before you start, you're going to write the problem on your paper, obviously. When you write your augmented matrix before you go, my biggest hint to you is to make sure that you've written everything correctly. Make sense? Because if I could work 20 minutes on a problem and get the wrong answer because I forgot this negative 25. I don't want to do that. These problems are long enough on their own. We don't need to make them longer. Okay.
Thank you.
Okay, so the elementary row operations that we are going to be able to do. We can interchange any row. We can move a row to the top. We can move it to the bottom. But we have to move the whole row. We can do that. That doesn't change it, does it? Nope, we're good. You can multiply a row by a non-zero constant. As long as I multiply the whole equation by 6, I can multiply it by 6, can't I? Yeah? Okay. Now I can add a multiple of one row of a row to another. Now you've noticed I've said multiply and add. Have I said anything about what other two things? Subtracting and dividing.
This.
Okay? So what it is they multiply or they add, what they do is they multiply by a negative and combine. And so adding, there is just, like I've said before, guys, there's no addition, subtraction. It's just combining positive and negative numbers. And so the biggest thing is we don't divide. If I want to divide by 2, I multiply by what? A half. Okay? There is no division in matrices. It doesn't work. We can add them, we can subtract them, we can multiply by a scalar, or we can multiply them if they meet the conditions, but we cannot divide matrices. Two matrices are row equivalent if one can be obtained from the other by a sequence of elementary row operations. So we will be doing these things. We will interchange rows, we will multiply a row by a non-zero constant, we'll add a multiple of one row to another, or we can just add 2 rows together. We are going to be labeling our work a specific way. When I show you how I'm setting these problems up, it's not a suggestion. Most of the time that's suggested, like here's a suggestion you can organize with. This is not a suggestion. This is how you need to do the work and label it. So did we, in elimination, did we multiply one equation by a non-zero number and combine the two? Isn't that what we did with elimination, right? To get rid of it, to get a 0?
Yeah.
That's 2 and 3. We've already done that. We've already been doing 2 and 3. If we were to solve a system of 3 equations or 4 equations or 8 equations in the methods that we've been doing it, you have to break them into 2 equations over here and then 2 over here, and then when you get left, you got to come back together. You have to run around in this big circle. So instead of doing that, we are going to be doing Gauss-Jordan elimination. So are we good? Everyone got these? Okay. So today we're just going to look at these things and figure out what happened. So we have 2 examples right here. Okay. This is the original, what I've started with, and this is what I've gotten. So we need to figure out what happened from the first one to the second one.
Can you read those numbers? They interchange 2 rows.
Okay, just a second. What did you say, Troy?
Can you read those numbers? Those are kind of small.
Okay. 0, 1, 3, 4, negative 1, 2, 0, 3, 2, negative 3, 4, 1. The next matrix is negative 1, 2, 0, 3, 0, 1, 3, 4, 3. Actually, I said that 0, 1, 3, 4. I said that wrong. 0, 1.
The 2, negative 3.
And then 2, negative 3, 4, 1. Okay, so first to second, Maddie, what did you say happened?
They interchange 2 rows.
They interchanged which two rows?
First two.
The first two. So what you do to show that, you can do it on the first or the second row because they both just interchanged. But I just write R1, R2. Does that pretty much tell you what I did? Yes. Everything you do, you will be writing what you did. Now, you notice I put it on the result. See that? It's not what am I going to do, it's what did you do. Isn't that the question you guys always ask me? How'd you get that? Right? You always ask me that, don't you? Okay. Now when you see these, are you going to know how I got this?
Yeah.
That's what you're doing. It's how you got it. Nothing else. Is there anything else that happened? No? Okay. Now, it's a little preview of what's going to happen. We're going to want ones here, and here, and here. And then we're going to want zeros here, 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 and here. I'm going to make that augmented. Do you see why they switched row 1 and row 2?
Because you already got 2 zeros.
I already have the 0, but I also have the 1,
That's what I meant to say.
right? So knowing what we want at the end can help us out. Okay, so what happened from the original to this next one? Did we change row 1? No. We changed row, did we change row 2? No. Again, I told you I was wanting the 1s and 0s, so I have a 1, I have a 0, I'm good there, right? So I wouldn't be changing that. What row did I change? I changed the bottom 1. What happened to it?
You added a multiple of a row to another row.
I added a multiple of a row to another row. Which row do you think I added a multiple of?
The bottom,
The second one.
the first one.
Well, if I did a multiple of the second one to the third, nothing would have happened to my, because I have 0. And that would be 0, right? So I would still have 2. Do I still have 2? No. I eliminated, elimination method, I eliminated this 2, didn't I? So we will get in the habit of, this is in column 1, yes? So we will use row 1 to do so. So what would I multiply row 1 by to get rid of that 2?
Negative 2.
-2. So what I do is I say -2 R1 plus R2. Yep, that's not R2. That's R what?
3.
3. You notice I wrote it right next to a change. So the next person that picks this paper up, they see -2 R1 plus R3. Okay, well, -2, so that'd be -2 and 2 would be what? 0. And -2 times 2 would be
Negative
-4,
4.
plus 1 is -3. -2 times -4 would be, nope, 8, plus 5, 13. -2 and 3, -6, and -2, -8. Did row 1 change? No. The only one that changed is the second one. Anytime we write these, the only one that should show any change is the second term. Got it? Now, for those of you who hate to show work, did I show any work? No. I did it in my head. Those of you who hate not to show work are going to have a lot of work over here and a lot of work over here, but nothing in your matrices. Your matrices are clean. Got it? You'll see lots of dots on mine. Did you see what I was doing? -2, 1. I have to touch it to know I did it.
Make it right time.
Okay? I'm touching what I'm doing. I'm doing this. Now, bless you. Well, sometimes I multiply both rows by something. Yeah, sometimes I will. Then Usually when I get my solutions, I get some big numbers, so you'll see some numbers random over here because I'm keeping my math straight. But this is what we're going to do, and we're going to keep going. Okay?
Wait, I'm sorry. So you took -3 times the first row on the original, and then took that answer plus the third row.
Yes, on the original. Yep.
And then made that your third row.
Yes. Yes. Now, when I do this again, okay, when I do it again, this is what I'm using. Like my next step, I'm not going to really explain why I'm doing it yet, but my next step would to be take R2 plus R3. So I wouldn't change row 1 or row 2. And so I would have 0, 0, 11, -9. See how I got my zeros? See how I was accomplishing that? Okay. That 3 is in column 2. What row did I use to do it? Row 2. Anytime you want to clear out something in a column, use that row. Then you won't add stuff back in. So. Okay. What is happening from one to the other? So this is a system of equations. Okay? So this is the whole process. Actually, this is half the process. When we get down here, we'll start going back up and make these zeros. Okay? But this is the first part of this. Okay, so here's our original. So this, what was the system that came from? What was the system that came from?
1x minus 2y plus 3z equals 9.
Equaled 9. And then
-1x plus 3y equals -4.
do I have to put plus zeros?
No.
No. And then
2x minus 5y plus 5z equals 7. Come on, guys, I'm trying.
now on their assignment, they're gonna have to. It says write the system from the augmented. You're gonna have to do that. So I just wanted to make sure we did it. Really easy, right?
Yeah.
Just going back. Because we need to remember that this is the X row, the Y, and the Z. Okay, so now, original matrix. From the first to the second, did the first row change? Did the second?
Yes.
I mean, yes, did the third?
No.
No. So we only looked at here. And if it was me, I would do these 2 steps in one. I wouldn't do 2 steps for it, but the book did too, so I just pulled it off the book. Okay, so how did they cleared out this right here, didn't they?
Yeah.
So how do you think they did it?
They took the
Add and
top one
multiply a
times
row by
something.
a non-zero column.
Yeah.
No. They added
They
They
times
just
the
needed
top.
to add. You didn't need to times the top one by anything, did you?
Oh.
Because it's 1 and -1. Can I just combine row 1 and 2?
Yeah.
Yeah. So this would be R1 plus R2. So 1 and -1 is 0. -2, 3 is 1. 3 plus 0 is 3. 9 minus 4 is 5. Now, guys, if we could add and subtract, multiply, we'd be good. Because, sometimes 2 times 3 is 5. And sometimes 2 plus 3 is 6. Because our brain just does it, right? Are we going to make stupid little mistakes doing these problems? Yes. You have to find ways to slow yourself down and to just make fewer than, I still make them, okay? But you're going to just have to go back and figure it out. Okay, so now we went from this step to the next step. Which row changed?
The third.
The third. Now, honestly, guys, I would not do this middle step. I would do both of these at one time. Because as long as I'm using one row, I'm not using a row that I changed to change another one. I can
That's just
do
how I
it.
confuse myself.
Okay. So, did I change the first row?
No.
Nope. And you're only looking at this one right here. Don't look at anything past that. Okay. Did I change the second?
No.
No. Did I change the third?
Yes.
Yes.
You take the top times.
Divided by.
No division.
Oh, no.
That's a bad word.
Multiply by half.
Okay.
No. That's all.
There's a couple things we could multiply. We could multiply row 3 by a half and get a 1 and then do that. Well, but then I'd have 5 halves and I don't want to do that, correct? Okay, do not give yourself fractions unless you have to give yourself fraction. Is it better to work with a bigger number than a fraction?
Yeah.
Yes. Okay, so this is in column 1, so we need to look at row 1. What can I do to row 1 to get rid of that 2? It needs to be a what?
Multiply by -2.
Multiply by -2. So -2 R1 plus R3. So then we would do it. So it'd be a -2, 2 would be 0. -2 would be +4, so -1. -6 and 5 would be -1. -18 and 17 would be -1. Do you have to be good with your positives and negatives?
Yes.
Yes. Okay. So now what happened from here to here? Did row 1 change?
No.
Did row 2 change?
No.
Did row 3 change?
Yes.
Yes. So row 3, this went to a 0, yes? And what column is it in? 2. So what row should I look at? 2. So how could I use row 2 to get rid of row 3? Just add them. I've 1 and -1, correct?
Why do I keep thinking?
I don't know. Row 2 plus row 3. Now, the reason why, can anybody tell me why I didn't use row 1 to get rid of,
Because it's gonna take more work.
well, if I used row 1, wouldn't I add back in a 1 in my first position? Yeah. I'd add back in something I already took out. Why would I do that? That would make no sense, right? So if I do this, so I get 0 and 0, 0, 1, -1, 0, 3, -1 is 2, 5 minus 1 is 4. Okay? Now what?
Now you multiply by half.
Multiply by half. Good job. Multiply row 3 by a half. Now at this point, I would only encourage you to do this 1/2 R3 if it went in there evenly. Okay? If it doesn't, let's say I had 5 and 7, you keep it. Don't do this step. Because we're going to start going back up. And you're going to help me do that.
Ooh.
Okay, so we got zeros. We got 0, 0, 0, yes?
Yeah.
We're good? And we've got 1, 1, 1.
Yeah.
That's good. We want that. Now we need to get all this to be
0.
zeros. Okay, so we went down. We went row 1. Yes? Row 2. And now we're going to go row 3 and then back to 2. So we go this big row 1, 2, 3, 2. What did we do?
That's a square.
Or a big circle, right?
But that's
We just
square.
went around. That's what we're going to do every time. Every time. Got it? You're going to clear, 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 clear. Put zeros everywhere. Okay, now then we'll do our 1s if we haven't done them. So I need, these 3s are in column what? 3. So I need to look at row 3. So what am I going to do to row 3 to get rid of the 3 in row 1?
Multiply -0.
To get this to be 0, that 1 has to be
Multiply
in
by
-3.
Yeah.
So I'm going to take -3 R3 plus R1. Okay. Now what do I have to do to this 1 to get rid of that 3? What do I have to do to that 1 to make this 3 a 0? -3
Why are you doing so many in one?
R3 plus R2. Do you see how I used R3 to change both row 1 and 2? So I can do that in one step. Because I'm not changing and using, I'm using 1. Okay? So now, I'm not going to change row 3, so I'm going to write row 3 right away. I find that this helps me not change it. I also want to point out, do you notice that all of my augmented lines are lined up? See that? I expect you to do that as well. Okay.
Go far out. Yeah.
So, now the matrices went far out, yes, but my augmented lines lined up. See that? That's what I was talking about. My matrices may not always line up because I may get bigger numbers, but my augmented lines always need to line up. So guess what I draw first in the whole thing? My augmented line. Okay, so -3 R3 plus R1. So -3 times 0 is 0, plus 1 is 1. -3 times 0 is, plus -2 is -2. Do you see why we clear things and then go back? Because lots of zeros make it easy, right? -3 times 1 is -3, plus 3 is 0. And then -3 times 2 is -6, plus 9.
3. -3.
3.
3. I was right the first time. Thank you.
So you do the next one.
Ah.
Now, this also goes to the fact is you always go down. Do you see how hard that is to go from the bottom to the top? Yeah. You guys will always go down. I don't have enough room. My board doesn't keep going. Okay? You guys only go down.
Gee, I don't like that.
I would suggest folding your paper in half. So you use one column for a problem and then you turn it over and you use one column for a problem and you only see one problem at a time. Okay, so you should have what?
0.
0, 1,
Zero.
0,
-1.
-1. Good job. So now I gotta clear what?
1 and 2. Or
That -2. The -2 is in what column? 2, so I need to use row 2. So what am I gonna do to the row 2 I have?
You're going to write it down.
Well, yeah, I'm gonna write down row 2. You're right. I'm not gonna change row 2 or 3, correct? I'm gonna write them down.
We're going to have to do this on every problem.
Not today, but yes. Okay, so what am I gonna do to row 2 to get rid of the -2 in row 1?
Times dependent to
2, not -2,
Not
right?
negative.
Just 2. So I'm going to do 2 R2 plus R1. Do you see where I'm writing it? I'm writing it next to row 1, yes?
Yeah.
Write it next to what's changing because that helps your brain just look at what's changing. So do it. Got it?
Uh-huh.
So what do you got?
1, 0, 0.
Okay, so you know what's happened now? We've solved the system. What column is the first column? X, Y, Z. So I have 1x, so x equals what? 1. Y equals -1, and z equals 2.
Oh, wow.
So my ordered triple
Okay.
is 1, -1, 2.
We're just too good. We figured it out.
Do you see how this process is cleaner than what you've been doing? Yes. It may take a minute and a little bit more writing, but it is a lot more organized. And you just go through the process. Okay. Well, you'll probably go full. I would suggest folding it in half. I will also tell you that in the past, I have scratch paper that's probably has stuff on one side, but people just take it, a bunch of it, punch holes in it, fold them in half, and use the no lines because it helps them not worry about how it fits on the line and everything like that. The other thing is you need to space your matrices out. I will have people not skip a line and they blend together. You need to space them out. If you're trying to scrunch things up, all you're doing is putting your brain in this little box and it's going to get all confused.
My brain's always.
Okay, I think I have one more for today. Okay. So then you're going to have to today follow their rules. They're going to tell you what to do. Okay? So interchange the first and the second row. Why would they do that?
To make
So that our
the
second
ones
one
line
and row
up.
two is
Well, because
The
the second row has a 1 already in the first place, yes? Doesn't
Yeah.
matter if it's negative, does it already have a 1?
Yeah.
Yeah. So interchange the first and second row. So R1, forgot my 1, and R2. So -1, 2, 0. Oh, don't start doing this to me. And then 0, 1, 3, 4.
Guess what they forgot? Their lines.
Well, this must not be a system. If there's no system, I mean, if there's no augmented line, did this come from a system?
No.
No. Or they just don't want you to worry about solving the system at this point.
So would that mean that the 3, 4, or the 4, 3, 1, that's not the answer?
Yeah, this is just a normal matrix. Okay, then the next one says do what?
Multiply the first row by -1.
Multiply the first row by -1. Why are they multiplying it by
To
-1?
get to 1 positive.
Get the 1 positive. So multiply the first row by -1.
Which is good.
What do you think people do when they do this? What do you think they forget?
To flip their sign.
Yeah, they forget to multiply it all by -1. Oh, come on. So you'd have 1, -2, 0, -3. Is anything else going to change?
No.
No,
How do you get a -2?
because you're multiplying everything by -1. You're taking -R1.
Oh, I was looking back at this first problem.
Okay. Where do I look? Only the one right above it, right?
Above there.
Okay, then what?
Add -2 times the first row of what to the third row.
Right. So why would I take -2 times the first row and add it to the third row?
To get rid of that 2 right there.
To eliminate
bottom
the
of
2.
that.
So I'm going to put -2 R1 plus R3. I make my decisions, fill in, and then do it. I don't try to do everything at one
Can
time.
you just write it in the middle row?
So I just write in the first and the second row because I'm not changing it, am I?
Oh yeah.
And then -2 and 2 is,
0.
and then -2 times -2 is 4. -3 is
Yeah.
1.
Yep.
-2 and 0 is 0.
Plus 4.
4. And -2 and -3 is 6.
6.
Plus 1 is 7. Okay? So today you're doing very basic stuff. The last slide where we went back up, that's just I want to kind of give you a prequel to what's coming. Okay? Today you're what's the order, what happened, do what I do. Okay? Have a wonderful day, guys.
Oh my god.
Is this on Fire Academy or whatever?
Fine.
Khan Academy.
Yeah,
I do not know if it is or not, but today just don't overthink it. Today all you're doing is what's happening.